now we're going to start looking at some examples of some application problems involving exponents and logs here in a little bit. So I'm going to run through 3 quick ones, and to get started, we're going to have these formulas. Basically, they're all kind of the same thing. They're a little bit different than what I did at my last school, so I'm going to investigate that some. But my last school, I did growth and decay slightly different, because growth and decay to me was pretty constant. So I used Euler's number. And mine looked like this, where if b was greater than 0, we had a growth, and if b is less than 0, we had a decay. But here it looks a little bit different. See, I can go down here and look at half-life, which is a decay, and I have the half here. If it was a third life, which doesn't really involve physics that much, it would be another decay. And if I had a growth, I'd have a number bigger than 1, 2, 3, 4, or 5. That's a doubling right here. So basically, what's happening to my population goes right in here, whether I'm double, tripling, or whatever. Other tidbits, this a sub 0 right here, and here, is my initial population, my initial amount of whatever I'm doing, whether it's money, bacteria, whatever. And this a right here is the amount after time t. We have a couple of things going on with this fraction right here. We have a little t over big T. Again, I did it slightly different at my last school. I'll figure out why they do it this way here after I talk to a couple of people. So this is going to be my time that's going to be involved in the problem, and this is my growth rate in relation to the time. Say something decays every 6 months or whatever, okay? Or 10 years, or things like that. Let's take a look at some examples. So here we have a decay problem, radioactive isotope. These are very popular in our math classes and physics. And let's just identify what's going on with this. So when we have our initial amount, a sub 0, all right, and we want to find out how much is left over. So how much would be our a right there, okay? And we have our little t right here. I mean, our big T, our big rate is, because it cuts in half every 520 years. But we only want to find what happens after 100 years. So we would set it up like this. We would have our amount, which we don't know, is equal to our initial amount times what's going on with the problem. We're taking half-life. And we want to find out after t years, 100 years, how this works out. So 100 over 520. So we just put this in the calculator. I don't have my Casio emulator anymore. I'm kind of sad about that. I want to get it back someday. My free trial for my TI ran out last week, actually, so I have to figure that one out too. So I'm going to just put this in my calculator sitting here on my desk, and I spit out 13.1 grams. Okay, that's all we're going to do. We could get it more complicated. We could take a look at this one. Initial investment quadruples, very nice. If you ever run across that, definitely jump on that investment. All right. After 20 years, well, guess what? That's going to be our rate, just like the half-life was our rate. How much would you invest if you want to have after 80,000 after 30 years? So this is my A after 30 years time. All right. So let's go ahead and plug this in. So again, I'm going to go ahead and write the formula for a sub n times n, that's a capital N, sorry, of t over t, t over my rate, time over rate, okay? So n goes 80,000 is equal to a sub 0. We don't know what that is. I'm a little bit off, on the board there. Let's put that back where it belongs. A sub 0, okay? And we're quadrupling. Pretty impressive investment. And it's going to be 30 over 20. So let's clean this up. Well, 30 over 20 is just 3 over 2. So 4 to the third half, that's square root of 4 is 2. 2 times 2 is 8. So that's just going to be 8. So I have 80,000 is equal to a sub 0 times 8. Divide, and that's going to give me 10,000. Very nice to turn $10,000 into 80,000 after just 20 years. I mean, 30 years. All right. Okay. Now let's take a look at this last one. Now this one is kind of strange. So here we have 2,000, and well, it's kind of strange because it makes no mathematical sense. I'll talk about that in a second if I do. So our time period is basically 4 years. So we're going to have to keep that in mind. Now this right here, we're just using time. So guess where that 4 is going to go? Right there. And we have an initial amount, and we want to find our final amount. So we can just knock this out pretty darn quick. Oh, wait, so we have our final amount. I should read the problem before I do these. So we have 1.89 is equal to 1.24. Oh, we're looking for the rate. Yes. See, I have a brain at times. C, and we're going to raise that to the 4th power. Okay? So again, our final amount, our initial amount, and we don't know this rate right here. We don't know what's going on with it. Are we doubling it? Are we tripling? What's happening? So we're basically finding n. Well, I'm going to divide, and again, I'm using my desk calculator. And then I'm going to take the 4th root on both sides. So 4th root of 1.52 is equal to c to the 4th root. Okay. And punching that in, I get about 1.11. All right. That's going to be my delta. Now what we're going to do, my rate. So we're going to have A is equal to 1.24, 1.11, and we're looking at 2013. So that's 13 years. And I just chop that into the calculator, and I get $4.88. Well, this is September 2019. So you think if you continued this pattern and put in, say, more years, gas would be well over $5 or $6. Well, maybe in California, but I just filled up for $2.20, I think, at Kroger. A wonderful 6 o'clock in the morning. And that's going to probably actually start continuing to decline because of the electronic vehicles that are going to be more prominent. I see more Teslas here in North Texas. And BMW, Mercedes, and all those people are pushing out their cars. I imagine Ford will catch up eventually because our production manufacturing lines are not geared for EVs. And that's going to cause a lot of disruption, unfortunately, up in the north on the manufacturing. So you may see some plant closures in the north, and they may open up in the south. Who knows what's going to happen? But that's a big deal. But you should actually see gas prices start to decline quite a bit because the demand is going to start shrinking. And our production ability has gone up. So we create these math problems that sometimes just don't make any sense whatsoever. Alrighty, I will get this published.